Hi class, this video is going to cover section 6.4, trigonometric identities. So there are several identities you have been learning throughout this term and you've seen and you kind of put in your back pocket. So we're going to make a list of those identities so we can refer to this list when you're doing your homework, and then hopefully this list will stick in your mind so when it comes to test time, they're easily accessible. So one set of identities we know is known as the quotient identity. Well, quotient means dividing. So we know that tangent of theta equals sine of theta over cosine of theta. So we learned that in a previous section. Well, if that is true, then we also know cotangent of theta would just be the reciprocal. Okay, so again, nothing new. We're just making a list so we can refer to the list when we're doing things. The reciprocal identities we learned actually the first day of the term, and that is, well, we know cosecant theta is equal to 1 over sine. Secant theta is 1 over cosine. And cotangent theta is 1 over tangent theta. So far we already have two definitions for cotangent, and it would just depend on the problem which one we're going to use, and that will make more sense when we go further into this video. Well, if all of these are true, then we know sine theta is just this reciprocal, 1 over cosecant theta. And then cosine theta is 1 over secant theta. And tangent theta is 1 over cotangent theta. All right, now we're going to get into the Pythagorean theorem identities. So this one we have talked about several times. Whether it has stuck in your mind or not, I'm not sure, but hopefully after this section it really sticks in your mind. So the Pythagorean theorem identity is that sine squared plus cosine squared equals 1. And remember, that's coming from that unit circle, right? You know, we can create a right triangle in the unit circle. Our hypotenuse is 1. Well, you know, y squared plus x squared equals 1 squared, and our x's and our y's are sine and cosine. And let me refresh your memory. Identities mean it works all the time. So I can put in any angle into these equations and it will be true. Where a conditional statement means only one value will work. All right, so what I can do with this sine squared plus cosine squared equals 1, because this is known as like my little cheat sheet, I'm going to rearrange the terms. So I could isolate sine squared, and that would be 1 minus cosine squared. And I could also isolate cosine squared, and that would be 1 minus sine squared. So again, we're just making lists of things that we know. Now, the other two that come from this Pythagorean theorem identity, we have talked about, and I believe it was like in 5.3 is my memory. Well, what we can do is we can take this identity and we can divide it by sine squared. Every single term. We can divide it by whatever our heart desires. I'm just using strategy because I know what I should end up getting. But remember, if it's an equation, we have to divide absolutely every single term by the same thing, otherwise it's no longer equal. Well, sine squared divided by sine squared is 1. Cosine squared divided by sine squared, well, we know that definition from up here. So we get cotangent squared. And 1 over sine is this definition, so we get cosecant squared. So this is one Pythagorean theorem identity, and this is our second Pythagorean theorem identity. Now for this one, I also want to go ahead and rearrange terms. So I just have a list of everything I possibly could use. I could isolate the 1. And then I could also isolate the cotangent squared. All right. Now your third one, I should say, I'm going to rewrite the identity that hopefully we can all have memorized. Sine squared plus cosine squared equals 1. Well, now I can divide each term by cosine squared. So, well, sine divided by cosine, here's that definition, and that's why we would get tangent squared. Cosine divided by cosine is, or cosine squared divided by cosine squared, I should say, is 1. And 1 divided by cosine is this definition, so that's why we get secant. So here's our third Pythagorean theorem identity. Now I'm showing you where they're coming from, so you would recreate them when it comes to exam time, so you don't have to have it memorized. And then for the same reasons I did before, I'm going to isolate each term, so I could isolate tangent squared. And I could isolate the 1. Oops. Okay, so all of these identities, I know it feels overwhelming, but you have been exposed to them before this lesson. And now we're going to make one more short little list, and that's our even and odds. Well, we know, hopefully, that sine, if I input a negative, it does affect my output. That's known as an odd function. Okay, well, if that's true, then we also know then the reciprocal has to be true. All right. We also know that even functions are a cosine, so when I put in a negative, it does not affect my output. Well, if that's true, same goes for its reciprocal. And if tangent's definition is sine divided by cosine, well, that's an odd divided by an even. You can kind of think of it as like negatives. Then tangent is also an odd. And that goes for its reciprocal as well. Okay, so we're going to refer to this sheet as we're doing this lesson. So have it handy. Maybe you don't want to have it stapled to the other sheets because it'll make it much easier. All right, I'm going to stop this video and we'll pick up an example 1 in the next video.